Oh, like macaroni and cheese?
The opposite angles.
Oh! We can't be friends.
So that doesn't say that it's
The bell ring or that was one of them.
I would start out saying that A is equal to C, so A is equal to C, and then B is equal to C, and then put that in. But I might have done it wrong. Yes, she did.
Alright, everybody. Hello. I'm teaching it again today, so hi. If you guys want to go ahead and get out your notes.
Pretty good teachers, but I really don't care.
Thanks. Alright, so last night you all were supposed to do example 4 for homework, and I know that was a more difficult proof for you guys to do, especially since it was Converse, but I'm going to give you guys an extra day, so we're not going to talk about it right now, we're going to talk about tomorrow, so you guys have an extra night to look at it, because we're going to do something today that should help you with this proof, okay? So we're going to go ahead and go to proof number 5. So we're still looking at proving properties of parallelograms, but we're doing converse proofs. So we're working backwards. So yesterday we said we were given a proof, and it said, or we were given a parallelogram, and from that parallelogram we proved that opposite sides are congruent or opposite angles are congruent. Today we're given that, like, so in this one, the opposite sides are congruent, so then we have to prove that the quadrilateral is a parallelogram. Makes sense? A little bit? Okay. So if we look at example 5, it says that if the opposite sides of a quadrilateral are equal, then the quadrilateral is a parallelogram. So your if part of the statement always has your given. So the given is opposite sides are equal. And the then statement has what we're trying to prove. So we're trying to prove that this quadrilateral right here is called parallelogram. So in prove, I want to say parallelogram. A, B, C, D. Okay, now I'm going to go ahead and label my parallelogram. And we know that the opposite sides are equal. So since we know opposite sides are equal, I'm just going to go ahead and write down which segments are equal to each other up here, so it'll help me visualize it. So I know that segment BA is congruent to segment CD, and segment BC is congruent to segment AD. Anybody have any kind of idea of a plan of where we should go with this proof?
So we said the angles are congruent.
Can you say a little about it?
Can we say the angles are congruent?
So yeah, so we need to work towards getting the angles congruent. Is there a way we can do that, Charlie?
Could we make an auxiliary line between B and D, and then prove those two triangles congruent?
Good. Yeah. So that's a great direction we need to head. So let's start with that. So our first statement is the given. So segment BA is congruent to segment CD, and segment BC is congruent to AD. And that's okay. Okay, number 2 is to draw the auxiliary line. So draw segment BD. And that's alright, so what's our next step be?
Side, side, side. Or, well, reflective.
What's reflexive?
Well, on BD, like, would
Right.
it be BD equals DB?
Right, yeah, no, good. So segment BD is congruent to segment DB. Reflexive property. Okay, so if we say that, then we have enough for triangle congruence, right?
Yeah.
So we have triangle ABD is congruent to triangle CDB. And which triangle congruence would that be? Side, 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 good. Anybody have any idea where we should go next? Our next step?
We know BAD and DCD are congruent. BAD and DCD.
BAD and BCD.
And those are
They're right, they're congruent.
and they're opposite angles, so that'd be closer to proving it's parallelogram.
Yeah. What's the definition of a parallelogram?
Congruent opposite angles and congruent opposite sides. Or wait,
Those are properties.
Yeah.
Two pairs of parallel lines. So yesterday we used Charlie. You got something?
Do you want me to say why they might be why it would be a parallelogram?
Yeah.
If we because we know angle C and angle A are the same because CP CTC. We know that the two lines we know that BC and AD must be parallel because of the converse of alternate interior angles. Right?
You're really close, but we wouldn't use angle A and angle C. We would use pretend this is our transversal, right? So we would use these angles. But yeah, so we're going to use converse of alternate interior angles. Okay, so I'm going to make these 1, 2, 3, and 4. So with CPCTC, we can say that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Okay, and that's just with CPCTC. So now that we know we have alternate interior angles that are congruent, we can say that these parallel lines, that we have parallel lines. Is that making sense?
What rule is that?
So that would be the converse of alternate interior angles. So we can say that segment BA is parallel to segment CD, and segment BC is parallel to segment AD. That would be converse of a IA. Because we're trying to prove that parallelogram. So we have to prove that those pairs of parallel lines, that those pairs of segments are parallel to each other.
So how do we use alternate series? I mean, you just explained that.
No, you're good. So with the converse, so with the alternate interior angle theorem, right? You start your known is that you have parallel lines, right? And then from that, you can go to that alternate interior angles are congruent, right? Okay, so for the converse, you start with alternate interior angles are congruent as your known, and then that shows that they're parallel. Your lines are parallel. Is that making more sense? Yeah.
So we use triangle congruence to prove that the alternate interior angles are congruent, and then if we know that they are congruent, then we know that lines are parallel.
Yes. So now that we know we have two pairs of parallel lines, we could say here's 7. So parallelogram ABCD, and then the reason is definition of a parallelogram. So is everybody good? Any questions? Make sure to ask lots of questions because we're getting ready to do an activity. You're going to want to know everything about proofs that you can know. So ask now. Yeah, Charlie.
If in a proof we were given that it's a parallelogram, and we wanted to say something is true because it's a parallelogram, would we use, reason would we use? Definition of the parallelogram or properties?
So if you're given the parallelogram and you're trying to prove, so if this is fluff, so you're given a parallelogram and you're proving opposite sides are equal, you're doing what we did yesterday. So you would still use triangle congruence, and then you would already know that the sides are parallel, so instead of using converse of alternate in AIA, you would use just regular AIA.
Okay.
Because you already know those are parallel lines.
Are you talking about the properties of parallelograms?
What I mean is that if you were given that it was a parallelogram and you wanted to use like AIA, would you just would you have to state that the lines are parallel, like before you said that the angles? Okay.
Yeah. You would say that they are parallel and then definition of parallel. Any other questions? Okay, so we're gonna do proof relay races. Ooh, get excited. So I'm gonna put you guys into teams and we'll go over the rules. Wait. Alright, so here's the rules for the relay race. Okay, so I'll put you into teams. Each team will have a copy of the proof, so everybody will have a copy of the proofs. I'll pass out, and we'll all do the same proof. So we'll do, everybody will do the first proof first, second proof. And then for the relay race, you only have to write, the only thing you have to write on the board is the proof. You don't have to draw a picture, but you can. But if you're going to label your angles, like 1, 2, 3, 4, like we've been doing, you have to draw a picture and then put where the angles are so we can see it, okay? You'll get 5 minutes, about 5 minutes, before we start to make a plan for your proof with your team, so everybody kind of knows where we're going. And then once the 5 minutes are up, the relay starts. During the relay, each member of your team goes one at a time to complete the proof. So, like if this group here is a team, you'll come up first and write something, and you can write one statement, one reason, or change something. So you can't write a statement and a reason. So I could come up and write angle 1 and angle 2 are congruent, and then I would have to pass it off to Emma, and then Emma would have to come up and write vertical angles. Make sense? Okay. So after you've written your one thing, you gotta hand off the marker to the next person, and then they can come up. Each person needs to go an equal amount of times or close to it, so one person can't just write the whole thing. Everybody needs a turn.
When she means or close to it, if there's 8 steps, that's 16 times. If you only have 4 people, well, 5 people, not everybody can go the same number of times. But everybody, you need to have like a system where everybody goes.
And then we'll also be keeping track of how many times you guys go, so we'll be watching. And the first team with the correct proof written on the board wins, and we're playing for homework passes.
Okay,
So-
this is serious.
Yeah.
Get your game face off.
So anybody have any questions? No? Okay. Charlie?
Is it one homework pass for everyone in the team, or they get one to split?
I don't know how you would split it, but okay. So team 1, we're gonna have over here by the window, I have Dairu, Cooper, Alexis, Bryson, and Elizabeth. Hold on, I wrote it on the wrong, Alexis team over here. Right here in this group, I have Avi, Emma, Reed, Braden, and Carly. Right here is Charles, Hannah, Matthew, Kevin, and Lexi, sorry. And right here will be Destiny, Tank, Kira, Marcus, and John.
Mark.
Yes. I'm leaving my desk. Let's go. Got this. Oh, we gotta see him from the camera.
We'll go over tomorrow.
There's only 3 of us because
Okay, I might. You'll have people up, so don't you?
Yeah.
How many?
we only have 3.
Yeah, there's only 3.
Oh, sorry. I'm gonna hog your paper.
There's 3. They got 2 3s and 2
I can help you. I just don't know what to write. Correct.
Read, I'm gonna
That
walk
thing.
through that.
I still want to sit here.
Charlotte, we're gonna walk you over there. Yeah.
Bye, Charlie. Goodbye.
Okay, we got lost the code was like all day.
You got my seat. Alright, you're gonna have 5 minutes of thinking time. And then, once the timer goes off, you can write something on the board.
Someone has to do
Explain with your group.
So I'll be talking with your team, come up with a plan.
I'm gonna do
Everybody knows. Like,
We have to all work on the same problem.
We're gonna have to, what's the word? Excommunicate you.
We were given the.
We don't know our basic dates.
I don't know. Rhombus is all the sides are equal, and then opposite side, opposite angles.
We just do the proof.
Okay, this is easy then.
We're all doing number one.
Oh.
Everybody do
How
number
can
one.
we get around this? They're not equal. Let's just do something. Wait, all the sides are equal?
And then you have to like divide this one.
Well, for then they'll start
Oh,
from B to A.
you need to like.
We're gonna have to.
Or this one. Because one is the rhombus goes this way and
Well, since this isn't on the scale. Since we're assuming that each of these sides are equal, even though they're not, we can do it anyway.
Okay,
just all do
everybody,
it.
real quick. So for number one, we're gonna all have the same points on our parallelogram, so it makes it easier. So the lower left-hand one is A, B, C, D. Okay. Everybody see that?
How did you
She
do
wrote it right there. She was hard to try to do this.
So you just do it clockwise around.
That doesn't.
Okay, let's just go.
Bitty.
It says AD equals AC.
I know that we draw.
Those are congruent. Those are equal.
Here's guys. Are those segments? That's it.
Okay, and that's
It doesn't say segment, it says AC.
this is the part.
So you're proving it's a rhombus, is where the rhombus is.
Is that true that these two segments are equal?
That's why you can't always go by the picture, because the picture doesn't look.
Is there a reason it doesn't have a segment?
The triangles are easy.
I thought it was like a.
I don't know.
Okay, and CD.
Yeah.
Alternative.
But don't we have to use those? Okay, well,
Yeah, right.
So it's not like how they usually do it.
And then you go.
definition of
These are
I actually know
Wait, what are we doing? BD.
reflective.
We
And then offset.
actually
Okay, and then
Can I Google the definition of a rhombus?
let's call this one.
Ask your P, they know what it is.
There are no like 90 degrees in a rhombus. It's just like.
And then we can prove that 1 is equal to 3.
It's like halfway between a parallelogram and a square.
Wait, but we have to.
There's like no 90 degrees.
We, okay,
So
we
all
know.
the sides are equal, but not all the angles. Like opposite angles are equal, but not all the sides are the
We
same.
don't know that.
All sides
That's what we're doing. They don't need to be cut.
So parallelogram, opposite angles.
So what have we done so
The
far?
rhombus is still a parallelogram.
Reflective and alternate
all sides are equal.
How do we know that it's same? Okay.
Okay, I get it.
There's a reflective line right here, which means its angles are the same.
So
No, we don't. Wait, A, B, C.
Yeah, we do.
sides are congruent.
A, B.
Guys, remember, as soon as this timer goes off, you can start writing on the board. Okay?
Oh, yeah.
One at a time.
Okay,
Okay, not these.
So these two, you forgot to mark.
I guess just triangle.
Yes. So we know, so we know 2 is equal to 4 and 3 is equal to 1. No, maybe not. So we just need to prove that 1.
They got it. They were done first. It was.
How do we know that though? Oh yeah.
So it's like 1 equals 0, 2, 3. And now we know those are equal.
But which ones, how do we know they're congruent?
Go.
We need somebody to write.
Alright, you guys can start. This group here, you're on the smartboard.
A, B, D, and A.
Yeah, you guys are on this.
A, C, D.
We don't know that angle 1 and angle 3 are congruent. But we don't know this line and that line are parallel. That one and that one. We know these are. So we know that.
No, we know these are, look. A, B.
You just need to write good number, right?
Okay, so we know they're congruent.
So that's so the triangle C D
Somebody needs to go out.
Somebody has to write given.
Which one are we?
The smart board with the terrible handwriting because you can't see anything. Oh. Okay. Just write number one. Write the
Oh no, I didn't write one. It's a crisis. We're all gonna die. We're all gonna die.
So what we just did it very easily. You can't see when you stand up there to write.
So excited. I'm not sure. Maybe borrow this?
No, I'm doing that.
ABB.
Yeah.
Wait, can I? So I just have to write that.
So
I know, I just have to write.
what is reflexive? I'll do.
Okay, so you only write
So we know the triangles are good.
I would consider
y'all are double up.
Angle side side.
Yeah.
Angle side side.
Kevin.
CBD is equal to 8.
Here, somebody has to go write reflexive because I wanted to. Somebody. So I finished my 3. And yeah.
Okay.
Or we change the opposite to
1, 3, 2.
So we know that they're good.
Smart board team. Smart board team. I would consider changing your arm.
What do you mean?
So go the other way.
She wants us to go CA. Duh. I said that.
Change our reflexive. We've already done this.
It's fine.
You can change
Flip
it.
it. And you can still use the same angle. I'll go fix it. I'm just gonna work with the other one. Wait, can I like?
Yeah, let me do side, side, side.
Then after that, change it to
We have
side.
to change the side, side,
We did
side.
our reflexive. I mean,
Somebody had, look, we have to change it. You have to go fix the second one.
Someone change the
Fix the third one.
reflective.
Since we fixed the one before.
No, it is reflective, never mind. I don't know. Just
So
do
are we doing each
triangle
one of these groups on the page?
Triangle ADC is congruent.
Are we doing this one next?
ADC.
No, not yet.
Okay.
Okay, now all of this is CA.
Then next one will be.
BC is congruent to AD. CBA is congruent to CDA.
triangle.
Do angle D is equal to angle B. Alright, I'll go with it. But are those the right triangles? Wait, no, that's not the right triangle now. Since we switched our thing. You have to make the triangles different now. ABC.
Triangle ABC is equal to
No, you segment congruence like AD equals DC.
I'll go with it.
that would be angle side angle. Should we prove that ABC?
Wait. We have a side, we have an angle, we have a side. We just say that they're. So we know that these triangles are congruent, which means we need to say that something is the case because of
In
CBC.
order for you to be on this
SAS?
Yeah, for number 5. That sucks.
Then the last one would be.
Okay, hold on.
It's just.
They all did SAS, we did SAS.
They did SAS.
It's fine, we know we're wrong.
How did they
It doesn't matter because we already have CBC.
we need to
Yeah, 6 would be
So this is like kind of about saying we need to do angle A and angle C are congruent. That's the hard one. You can't just write it down.
You can't try it down and say that.
Alright, I'll go put that up there. What is it?
Angle A,
Is equal to
and then
angle
Diagrams are group
Angle
finish.
BAC is congruent to angle,
Not 100%.
yes, no, it'd be ACD. Angle BAC congruent to angle ACD. And angle DAC congruent to angle BCA.
I just didn't know.
Yeah. Okay, what do we have next?
Nothing, we have nothing. That's 6, that all.
Now we need to prove these are equal.
But we have to have the other 2 angles wrong. No, but we're not gonna win.
Well, we know that A and C, whatever it is. Yeah, A and C, angle A and angle C are equal because CBC is the same. No, that's.
And we have to angle.
I don't know. And I'm gonna tell you that everything right now is getting nothing been up and down.
We're done.
I know, I spoke it wrong, forgot the age.
What would the next step be?
Okay, angle addition. So
Just say
we know that angle 2 equals 4 and 2 equals 4 and 1 equals 3. So we can just say angle 1 plus angle 1 plus angle 2 equals angle 1 plus 3 equals 2 plus 4 because segment angle addition. I'll write the statement. Base is angle addition.
I think we have to say angle BAC plus yeah, just write it wrong.
We're not done.
Or angle addition. Okay, so we know that. So now we've proven that this is equal to that. These two are equal. We know how are we going to prove that these sides are equal?
Wait, are these equal?
Yeah,
Sure they equal.
because we know they're parallel. Wait,
No, we proved those equal.
we know that the sums are equal. So yeah, we know that that is equal to that, and that's equal to that, and we also know that this.
Miss Wiley,
Versus.
I need your help. Miss Wiley.
Everybody finished?
No, Miss Wiley, we need your help. Like, we're lost.
Okay. I mean, how lost are you?
We found.
So if you're super lost, we'll just go to the next one and go there.
No, I'm lost from
Personally, I'm
6.
super lost.
I got down way 5.
So that's,
You guys finished? Alright, you guys got done first.
What's the thing
However,
Same side.
with
All the sides are the same, and the adjacent,
It could have gone
the
side
opposite
side.
angles are congruent.
this is given congruent, this is given congruent, this is expensive.
Angle
But when you name
Say that again?
your triangle, you went A, B, C, and then you
So
did
basically,
C.
you know
We know
that
that
these
these
two are
sides are
parallel,
congruent.
so you need to show that
And
these two are
wait.
parallel
And then A,
and that they're all equal in
It's in
length.
the given.
That's where you're going.
yeah.
Well,
So how could you
But
say
you
these two are
did, in
parallel?
order for it to be rhombus, you have to.
and you're just saying because of CBC.
we know that these are congruent, those are.
Not parallel.
all we just say these are.
We just converse of alternate interior angles.
That's about a rhombus.
Yeah, we're just gonna, we'll go over it tomorrow. You
You have to
guys
say that
will.
it's a parallelogram, and then say it's a rhombus.
Then right
And you guys here didn't say that it's a parallelogram.
Are you all done?
So you have to say that it's a parallelogram, and then, and I think you guys did the same thing here, that they did here. You named the triangles in opposite directions.
So is everybody done then? Yeah, okay. Well, I don't think any of the groups have it right. So what we're gonna do is you guys are gonna do what we don't get through today, you'll do for homework tonight. So go back over this one for homework tonight, and then we're gonna go over it tomorrow at the beginning of class, okay?
But you first need to show that, you have to show that it's, all sides are equal and it's a parallelogram. The order doesn't matter, but you have to show all sides are equal and it's a parallelogram.
It's a square that's been tilted.
Alright, so next proof is number 2. You all have 5 minutes to work on making a plan.
Hey John, I need some light.
RS. Well, we know that RSTU is rectangle.
Let me
In all angles.
opposite sides.
Are you in?
In all angles.
That we can prove that those two triangles are different, then we can prove that
In this midpoint.
these sides are different, you can say two
We
triangles.
can, using midpoint, we can say that, these are.
I will show up on what you have on your picture so you can visualize it.
have to prove
So we know that.
Because once you can visualize, it's really easy.
We know RM and MS are congruent
So
because
we can subtract the definition of the whole.
Then we can do,
We got it. So using midpoint, we know.
Make sure you're planning with your group and not just one person in the group.
then like, we say that RU and ST.
Yeah, let's just try and make it.
All the six sides are.
We have to make the statement that we know these two are equal to the rectangles, right? Yes, all boys are the same. We are not detrimental.
we don't. Oh yeah, right.
Well, you said
We're
it's
gonna
not
prove that RM and SM.
And then if we have triangle congruence, then we prove that UM.
We're gonna skip number 2 as a given. Number 1 is writing it down. We already know what the given is.
Yeah, and then the angles are.
And 2 is just definition of rectangle. That'll just be that.
No,
Yeah, I just
definition
write
of
the, it's just write that.
RM.
We'll write it.
Then after, when we got all of that, we can say definition, I saw someone's these two sides are equal, then the angles will be equal.
Now we can prove that the triangles.
If we have two congruent lines,
Because of
We don't have to do as much math.
Well, we also need to say that RU and ST are when we say that triangles are. So
already know that.
but we have to state
We
it.
have to state it. Yeah.
So RU equals ST because it's a rectangle.
You just write if
you're doing
the triangle belongs, then there's all things.
We don't have to do colors.
You don't need to write it down.
And then we'll have to
This part of it.
And then we just we cover all the stuff you guys do.
and then we can, if we have that, then we can say that's and we can say,
Yeah, and but we also have to say, so we don't take as much math,
UMD
we do
Because
how to give tests, how to just do lesson plans, all that stuff.
I mean, if we have congruent sides and congruent basics, then we can just say definition.
okay, and now we know that
Yeah, because a rectangle is parallelogram, right?
Yeah.
And we know parallelograms
we
opposite
should
sides.
do these.
So yeah.
So we have this one, we just need to be quick.
Then we have to draw a picture.
Yeah, we can draw a picture of it.
Okay, we have. If we wanted
And make
to
sure you say that
state
they're
that
90-degree angles
this
before you
is
say
equal to that and these are right angles, could we do that just this, comma, have another person go up and write this, then have another one write that?
Okay, so RL, so that's RL and MS. What's your reason for that?
Because definition of midpoint.
Okay.
I'm asking about, we were trying, two things are proven by it being a rectangle. It proves that that and that are 90 and that this is equal. So if we wanted, could we just have that and comma,
Yeah, given a
then that,
rectangle R.
and then
Yeah, so
say-
one person can write this, comma that, because that's one statement, yeah.
Okay.
Wait, so can we prove that angle U and angle T are equal, or just that?
We know that 1 plus 2 equals 90, and I'll write all the stuff about definition of rectangle as one statement, and I'll just say everything we know about them. So, and then we'll need, so once we have the two triangles are congruent, we'll need to say,
We have to say these are the same. Since we know these are the same, subtract them.
yeah, so we'll need to say 1 and 4 are congruent because CP, and then we'll need to say 2 and 3, 1 and 2 are congruent because
How did you know this?
Can you use the definition of isosceles?
rectangle.
To begin with.
Okay,
Okay, so let's say 1 and 4, angle 1 equals angle 4, CPCC, 6, and now,
we already tried to get them when you write. Okay, and we know that U, angle U is not. I'll have already written angle U and this are 90, so we'll already know that.
so we just have to say angle U minus angle 1 equals angle 2, and we do that on both.
Yeah, angle 1 plus angle 2.
No, we don't do that. We already know these are angles.
I know, but
So we don't actually need 5 right here.
so what are we gonna say?
So we gotta say MU is equal to MT. Say MU is equal
First
to
commas.
C right, C.
Oh yeah, we just need to say that. We just need to use, yeah, RM equals.
Okay, and then that just says definition of it.
Yeah, so we just need CPC, which means we just need to get up fast.
Yeah, okay. You can do this.
You go next. Wait, I'll write the definition the correct way. She's doing which one?
I'll write definitions.
Thanks. And then we'll need somebody to write their congruent.
What's step 2?
I don't know numbers. We'll just say, yeah.
This one's actually really hard. You don't need writing.
Make sure that it's legible.
Charlie's gonna be a third one.
Hey, Lexi, Hannah, you guys back up a little bit. Okay. I don't want you to block the path of the smartboard too.
And then the next one will be angle 2 equals angle 3 because if that
Definition of rectangle.
well, do definition of rectangle first. Okay, we have this, and then we can prove it.
Yeah, once we have congruence, we can just say that's.
And then we just say U and T.
Don't listen to him.
Listen to me.
And then
He's doing 5.
Marcus.
Okay, you change subject. That's right now, I think. Whose turn? We need. I'll congruence. And then I'll 4. Yeah, 4. Just go to 4. Be speed. Godspeed.
If that long table wasn't there, it'd be so much easier.
Well, what if you, or I
We
can
could
go
move
and
closer.
say this. Oh yeah, we should move closer. We can just have like John's together. Next slide. You have to do that, basically. Somebody needs to be ready to do SAS. Let's just feel like. Who's doing the sides? I'll do that.
Or opposite sides.
Somebody be ready to do.
No.
MU is MC.
If you're done, have a seat so we can see.
If your group is done.
Yeah, if your group is done.
Somebody needs to write that definition of grapple. Because CPCTC.
Oh, well. Stop for like a bit.
No, it said MU is equal to 90, so. I
Let's put this one.
Okay, who got done first, blue or red on the whiteboard? Alright, do you read what the blue says? Good, yeah, I know it's a race, but.
maybe we're just stressed that someone will judge us.
Okay. So blue team had it. It's right on the blue team, and it's you guys done first, so you guys won. Congratulations.
Happy with it?
Okay, now, what I want you to know about the one in blue over there on the whiteboard, you have to say that the opposite sides of the rectangle are congruent because opposite sides of the rectangle are congruent. It's a definition of rectangle is just that it's 90, it's a parallelogram and it's 90 degrees. So you have to, so in red here, your reason number 3 should be opposite sides of rectangle congruent. Because it's a property of a rectangle, it's not the definition. And it's a slight variation. But other than that, you guys, your proof looks good.
Do you want me to change that to take a picture?
And your step number 8,
You don't need it.
yeah, take out step number 8. If you want to take a picture of what's in blue, since it's perfectly correct, then you can. However, if you can read it, you get even more bonus points because that's insane. So if you want to take a picture of the blue one, and then copy it down on your
Yeah,
homework,
you just have to say that
or
those
you can just
two are
adjust it.
congruent.
But what's in blue is correct. But if you want to take a picture, go ahead and do that now, and then we're gonna do another one.
Yes.
Alright,
Alright, so we're moving on to proof number 3. We're gonna give you all 3 minutes this time, so we can fit this one in to come up with a plan.
We should have started on this
So,
like immediately.
Get started.
But I thought we were done. Okay. So a parallelogram just has 2 sets of parallel sides, which means
So we just have to prove that
because we know R and how do we prove something? So we'll need to prove that the angles are.
I might be completely wrong, just give me a second. These two. are congruent because and then so if you split it in half, then those that triangle and that triangle.
I don't think so. Because we don't know if it's split entirely in half or if it's like off to one side. Does that make sense? Maybe we can just prove with, we know that we know that D is equal to this because of alternate interior angles. And we know that D is equal to the left side of R. That's a goal. And we know that we can say that the right angle of S is the left angle.
RB is congruent to RB and GS. Well, RB, it's reflective, so they're the same line, so their RB is congruent to their parallel to GS. RB is congruent to GS. But I don't know if the word is like,
I think
yeah.
Then we can prove that
It is, but I'm not saying you can make both of them.
What about same side?
We're doing RB.
Yeah,
right.
but we have to prove that because
Wait, which one are, we're on, yeah. I'm not sure. Because we know what the given is.
I'll go right now.
We don't even know.
What you're doing?
I'll just write down.
We have nothing.
Well, I would mark down what you're given on your picture so you can visualize it.
I guess just
Okay, parallelogram, RB, bisects, ADC. So we know that both
I
sides.
think it's unfair that we have to do this one. It's slower.
Well, if we had more whiteboard space, I would have you guys on the whiteboard too.
I think we should have to like switch with.
And if we knew this stuff, we would be faster too.
It's slower.
They just have a hard time writing on it. Because like if you write sometimes, especially when you lower down, they stay in front of it so they can't see themselves right. Yeah.
So yeah, we already.
Okay,
Like maybe next
so
time we just
because
do
RB bisects ADC, we know that ADR and RGC are congruent, and SB bisects CBA, so we know that,
Oh yeah, I don't even.
so we know that,
So we're not good for those two. Great question, right?
That's all we have.
we know that ADR is equal to RDS, and we know that this and that are equal and that are equal because they're bisected, so I'll just write that.
Okay.
Think about your properties of parallelograms. What do you know about parallelograms?
Alternate.
if you are using numbers for angles, make sure that you draw a picture so that your number one is what is in my head as angle number one.
It's so pretty outside.
You'll know by third period, we get called off early anyway because they have yeah, so it's hard to call off early because they call back to bus drivers. They don't have second jobs.
I think it should be opposite sides congruent.
They almost called off GCGC. Not a lot, but there's some parts of the road that are slick.
Yeah, I slipped down some steps this week.
That's about how my morning's going.
got there and then my car was covered in ice. And I said, oh, that.
Okay,
We can do ADR.
There's some warnings where if I just follow it.
Well, I don't know. No. Okay. Let's just keep writing randoms. We know that.
Think about your properties of parallelograms. What are your properties?
Well, we can say
AB is congruent to
we have angle side angle because A is equal to C and
Yeah, we
C.
do. AB.
So we know that these two are
A messed up. You
congruent.
just say that
C
is equal to
only
BR.
says that these
Yeah, we should do that. But a property of a parallelogram is that
Opposite
that is
sides are
congruent.
congruent.
Opposite angles and opposite sides are congruent. Okay. Yeah, we just write that A equals C and B equals D. A, C.
Okay. Wait, what? D and B. Okay, I got it.
But
Really? Okay.
We already did that.
okay. We're a little behind, but at least we get it. Maybe. Do you guys get it?
Angle R, angle S if you want to do something. Because you have to say that they're congruent before you can do something.
Okay, so say that angle
S.
ASC is equal to angle.
Okay, I think I know how we're.
Charlie, she asked a question.
What? Equal or congruent?
For the reason.
They're congruent.
Oh, okay, that's what I thought.
And the definition of the opposite side.
All sudden there's C and then
Yeah, opposite sides of the diagram is opposite angles fit parallelograms.
Okay, what?
Yeah, do that.
This,
Do angle ARD to angle BSC.
Like ABSC.
I didn't write
Oh.
This one is
you have to do A, you have to do
Okay.
I forgot to write P gram, whatever.
Okay.
that.
That'd be
And then what?
this.
A and D and B and C, that's what you should
BSC.
You have to be done by the bell. If you're not done by the bell, don't count.
I'm just gonna put it in the paper.
Are congruent. That sounds good, but no. But I understand your pain.
See, that's also really annoying. And then when they say it right there. And then you can get the
You can easily prove it. No, but they use it for an angle addition.
Do a little. Inside your proof.
Is it plus?
Man, I like your shirt.
Okay, and then you could say, this is a proof for BSR and this is the angle for BRE.
Yeah.
We don't have any.
No, it's a supplement.
We were set up from
But once you prove it, you won't be.
What that's
Is the big
Yeah, we did it, that was our very last.
supplementary angles.
And we did, we went through the whole process, we proved in classes. And that's what we got to do. But like our draft test did that, there's an AC,
Supplementary
angle, so we have logic and sense. Yeah. Yeah. Did we already put table disorder in the hot? Opposite sides.
I have the extended version.
Yeah, we do too. We had a.
So I don't watch it when it's not extended.
We me and my friends had a Lord of the Rings movie.
I'm not remembering the books.
Guys, remember whatever the proofs we don't get through today, you're doing for homework.
Did anybody get finished with their proof? This one's tricky, so work on it and finish it. We'll talk about it tomorrow. Right.